right, in the last section, we learned by reading a word problem, an application, how to set up a differential equation. This section gets into solving the solutions of differential equations. So a differential equation is an equation involving the derivative of an unknown function, all right, as we said before. A solution then to that differential equation is any function that satisfies the differential equation. If we cannot figure out an actual solution, we can estimate it using Euler's methods. Euler's method. And sometimes you can actually find exact solutions with either separation of variables or slope fields coming up. But what if we actually have a function? So go back, we talked about the population of fish increases at a continuous rate of 20% per year. They're being harvested, their rate out at 10 million fish per year. So my change in population over change in time is 20% of the population at a particular time. So now this is an actual function. And then minus the harvested at 10 million fish per year. So if I want to find a function giving p in terms of t, then what I could do is I could kind of look at this and say, suppose at the beginning of time, I have a fish population of 60 million. I can substitute my p into the differential equation to compute the derivative. So in other words, again, this would be like saying p of t. I'm plugging in p of 0, which is 60, and then this gives me a number 2, which means what? Well, this is a rate. So at the very beginning of time equals 0, the fish population is changing at a rate of 2 million fish per year. So I could use this then to figure out, well, then the next year, if it's changing at 2 fish per year, I take where I started, the 60, and then I would add the rate that it's changing, and then I'd get the next year. So at t equals 1, my population would be 62 million. So now I can use this to estimate the rate during the second year. So my population has changed, my rate's going to change. So notice even my rate went up to 2.4. So at t equals 1, the fish population is changing at the rate of 2.4 million of fish per year. So at the end of the second year, I would take the previous year, 62, how it's changing, and now I can update, as you can see, Euler's method, I can update for my new population. And you typically do something like this with a table. So my initial and then how it's changing. So notice my rate is changing. And so now I could predict, say, 7, 8 years later using this method.